Hello, Professor. This is the final project video submission, and we are a group of two people. It's Dhruvkumar Parmar and Rohit Kumar Boma, and our project is automated parking database management system. So the table of contents is introduction and some background with each query explanation, then ORM and relational schemas, then tables, DML, DTL statements, procedures, triggers. Then we'll do installation of Couchbase. Then we'll do some nested entities from ORM, nesting buckets to insert into own buckets, and then construction of JSON documents, some data insertion using queries and loading into SQL using analytics, and then we'll do conclusion. So the summary is like most of the time people cannot locate a suitable or sufficient parking space for their cars, and as a result they obstruct public roads. If they do manage to obtain a parking spot, there is no effective system in place for handling tickets when there are plenty of vehicles. So the smart parking management system is a database that compiles customers and vehicle information and generates information from it. Prior to purchasing a car, the buyer must disclose their details like whether it has wheels or a four wheels. So based on this data, they will be able to choose the kind and parking space. And the introduction is most of the time individuals end up encroaching on the roadways because they cannot locate good or sufficient parking spaces for their cars. There is no efficient ticketing system which must be controlled when there are many vehicles. Even if they have a place to park, automated parking management system reduce the width and depth needed for a parking place as well, since no space is provided for maneuvering the cart into position or opening the door. So we had developed a database management system for automated parking lots, which include features such as automatic number plate recognition cameras and RFID based automatic entry, as well as various modes of payment such as RFID, online banking, card, or cash at the time of exit via an automatic pay machine. So our system is basically used to compile data based on information about all clients and on their vehicles. For that, they must have to provide their details like they have two wheels or four wheels, and based on that, we'll determine the place where it is based for parking spots based on that. Then we'll discuss about some importance and background of the data. So there is no need for a parking guard. It saves us time because the system only needs little maintenance. The system correctly maintains the entire systems, and the primary goal of this automatic parking system is to eliminate the confusion, turmoil, and lengthy lines at the entrance and departure of parking spots found within public buildings, such as offices, shopping centers, on street, off street, and multi level parking lots all require this kind of parking infrastructure. So, the primary benefits of this system compared to conventional multi story car parks are like amount of land needed can be decreased for 70%, volume reduction in buildings for up to 50%, and we can achieve 12% return on investment when compared to other forms of transformation. Driving generates up to 85% less CO2. So there are some list of queries that are answered as part of the project. So these are the three stored procedures. At first one is perform a specific method to gather all the consumers information, and then makes a stored procedure that searches the customer table for customer from a specific state. Then there is a SQL statement creates a store procedure that select customers from a particular country with a particular state from the customer tables. Then we'll discuss two triggers, that is, first one is whenever the country name is blank, the update procedure and numeric values are triggered. If not, the data on the user's record in the customer database is used to change the country name. And the second one is trying to perform a trigger update on extended given name and setting it to not applicable. Then there are some question and the results. The first one is how many automobiles were parked at once, what vehicle is parked in a certain parking space, how many parking spaces are available, block list of customers in particular interval of parking slot with charge for the vehicles, find the parking details of customer using the customer ID. Then we'll discuss about the ORM diagram, and in this ORM diagram there are entities given and there is some attributes related to it. So the first entity is customer, and it has first name and vehicle name and state, and last name, extended given name and country. So the first name and vehicle name has a and country has a uniqueness consent on it, and then there are some parking slot entity where it's connected to parking slip and parking type and floor and block. So block has a primary key and it has a domain value as a number of floors and floor list. Then parking type and has a two-wheeler and four-wheeler, so it will decide whether the car is two-wheeler or four-wheeler. And then we have a floor entities which has a parking slot list and number of parking slots. And the first one is a parking lot which has block list is fully occupied, number of blocks and the block. So number of blocks and block list has uniqueness consent on it. Then we'll see some entities that is discussed. Then we'll discuss about the relational schema. In the relational schema we can see there are blocks and parking lot, floor, parking slip and two-wheeler, four-wheeler, all the tables where each of the entities their primary key and foreign key is mentioned, where you can see the block has primary key as block name and foreign key as parking lot code, and second foreign key is parking slot ID. Then the parking lot has primary key is parking lot code, and the floor has primary key is floor number and foreign key is parking slot ID. Then parking slip has primary key is parking slip ID and foreign key has parking slot ID. Then parking slot gives parking slip has parking type as parking and foreign key, and this all are connected to each other and gives arrow to the other attributes. Then we'll discuss some tables implementation, data types and column constraints. So there are the values that has primary key and foreign key and not null. So the not null will give the value that should not be null, and the primary key mentions the uniqueness constraint which accept only unique values, and foreign key reference the data from another table using a common column attribute to fetch the data. So these are the attributes that is given. Then we'll do some DML DTL. So these are the queries that is performed in the SQL. So using the data manipulation language, it is utilized to alter the current data in order to insert data into student university admission in database to update any existing data. We have employed commands like insert and update. And what does data definition language do? So it's basically used to define the structure. We have used some DDL command like schema and create command for creating the database for our project, and alter statements to manipulate the structure. Then there are then we'll discuss about the procedures. So there are some three stored procedures, one and then two and three. So in the first stored procedures, we'll get all the customer details as a particular procedure. So this is the code, and we perform the code, and this is the output. And the second stored procedures is to create a store procedure that select customers from a particular state from the customer table. So we'll use this code to get the particular state from the customers table, and this is the output that is displayed. And the third stored procedure is SQL statement that creates a stored procedure that select customers from a particular country with a particular state from the customer table. So with that, there is code. When we'll execute the code, the state is AK and country is and Z, and you can see the output over here. So the next part is triggers. So we'll discuss the two triggers values. So the first one is triggers to perform update operation and setting default values when the country name is empty, else the country name is updated according to the given data on users entry on customer table. So these are the code that discuss the triggers to option, and then after executing the triggers, this is the value. This is the trigger has been executed, and if we do the select star from customer, we can see the output over here. Then we'll discuss about the some query results. So first one is at one time interval how many vehicles are parked. So it is showing over here is two number of vehicles is parked. Then we'll do the second question is, so this question is at a particular parking slot which car is parked. So when we execute the code, it shows is Hyundai four-wheeler names. And the third question is how many parking slots are vacant. When we execute the code, it shows two cars but parking slots are available. The fourth question is list of customer in particular interval of parking slot with charges for their vehicles. So when we execute the code, it shows first name and last name and parking charges for that. And the fifth question is find the parking details of particular customer using customer ID. And when we execute the code, the output is this first name, the block name and parking lot code and the parking slot ID. It is mentioned over in Northwest and Mercury and 2412. So the part 6 is NoSQL part, and for that we have to download Couchbase server. And after downloading the Couchbase server, we have to create two buckets named customer and parking slip for our project. And then once we created the buckets, the entity data we are extending by nesting are this customer, parking slot, parking lot, parking type, parking slip, block and floor. So you can see over here the two buckets that are created. First one is these customers and second one is parking slips. And we need to make sure that we have to create primary index on both the buckets, that is customer and parking slip. So first we'll create primary index on customer. Here you can see we have created a primary index on customer and primary index on parking slip. and then now we need to create the JSON file for both the buckets. So we combine two or more entity into nested documents, our customer buckets. So you can see in the customer buckets we are inserting the values. So these are the keys, which is C1, and these are the values for the C1, which is customer ID, name, first name, last name, other names, extended given name, state and state ID, state name. And for that we had combined two or more entities, and then we'll insert the values in the parking slip, where the key value pair, the key is 1 and the values are given over here. That belongs to the key is parking slip ID, customer ID, parking charges, and date and time. It is all the data that is presented over here. And the section 6.3 is JSON document for the customer bucket. Here you can see the my cluster query that is executed over here. So this is the customer bucket that is created. Then this is the parking slip bucket that has been created, and these are the values that is uh, executed in the Couchbase parking slip that are inserted in the parking slip. Then we'll do the SQL plus queries by using analytics service. So first we'll select the first name and the country name. So these are the queries that will fetch the country name and first name and parking slot ID, state name and vehicle number. So we have to write this code for that. Then these are the second query which fetches us the parking charges, estimated amount, tax and total amounts. And the third query is once we execute this query, we'll get parking slip ID and parking charges for each vehicle that has parking slip. And the fourth query is so the fourth query will execute will get last name and parking slip ID, then state name and vehicle number. Then we'll perform the join queries. So it will combine both the queries and will give the common output which is combined in both of the tables. So we'll get the customer name and parking slip number and amount charged from both the tables. Then we'll perform the inner joins, where we'll get parking slip number and amount charged for that particular person. We have the customer name and vehicle number. Then we'll perform left outer join, where it focus on the first name and customer name. So based on that, there is a summary from the automatic parking database management system. On that, there are numerous fields connected to obtain information based on several limitations that would be advantage to a person. So we feel that data is suitable as a foundation for other initiatives that are closely connected to other automated parking system, because all the problems we raised were satisfactorily addressed. So um, based on this project, we can conclude that we believe this project is useful for easy maintenance of the parking slots and management, instead of people wasting their time roaming around the park lots to find if there is an empty space. And implementing the ideas using data structures gave us a good walkthrough on the concept, and were able to connect to real-time scenarios with the concepts that were covered as part of our projects. Thank you.